Cool.
All right, started. Go for it.
So I was thinking we would start just with the self-assessment stuff. Tim, I don't know if you want to lead that, or we should just go through the questions.
I think we should go through the questions, but maybe I can give just a bit of background. So we set, and with a bunch of the SIG topics at hand and the various leads of the various areas, trying to figure out what was going to go on for 1.6. And there's a sort of general sense across a lot of people and a lot of conversations that some of the subsystems of the project are healthier than others. And is I guess the polite way to say it. And it was, there was a lot of people who were asking about, when are we going to pay down debt, or when are we going to have a stability release or maintenance release or something like that. And we didn't really want to throw down the law and say, well, 1.6 is going to be a stability release only, no new features. We felt that was a little draconian, considering that some of the SIGs and some of the subsystems are actually operating fairly healthily, like storage has spent the last quarter basically doing tests and not much else. And so it didn't seem right that we would blanket ban them too. So we decided, I think, to take something a little more self-reflective and ask each of the SIGs to look at the work that they've been doing, the work that they have planned, and the state of the subsystems that SIG represents, and try to come up with an honest assessment of how healthy do you think it is? And if the answer is anything less than pretty good, then what can we do to make it better, and how little can we get away with doing in 1.6, and instead shifting energy to stability wherever possible. So that is the introductory explanation for it. I was actually going to pull up I don't have the notes up here. Where is it? November, the doc. Here we go. So from observing a bunch of the other SIGs, this SIG operates a little differently than most of the other ones. Most of the other ones are more development focused. They're more like working groups in some sense, whereas this group is more of an idea foundry and a sounding board for us to check off against each other on our needs. But the first question here is, do we own code in the Kubernetes repo? And I think the answer is clearly yes, right? I mean, we have all of the plugin related code. We have all of the KubeNet stuff. We have all of the kube proxy stuff. We have all of the DNS stuff. We have all of the ingress stuff. So there's clearly some large volume of code that we own. I would be shocked if the owner's files actually represent appropriately. I have not updated them recently. I would be surprised. It would probably be worthwhile to go through those owner's files and see what changes we might want to make to them. Sorry, I see somebody popped up on chat too. There we go. Okay. So yeah, we should do the owners. The second question then is, do we spend enough time responding to user issues on GitHub, Stack Overflow, etc.? What do you guys think? Our own SIG mailing list is pretty low traffic.
I think the mailing list is pretty low traffic. I find that I do spend a decent chunk of time personally on Slack chatting with people. But
I see you there frequently.
Slack seems to be more user support as opposed to, development focused or sounding board for ideas and discussion.
Yeah. Well, this question is specifically, does your SIG spend enough time responding to user issues on GitHub, Stack Overflow, mailing list? And it didn't say Slack, but I assume Slack is in the same category. Yeah. I mean, let's be frank, like one of the top things that people wrestle with when they're setting up Kubernetes is networking, right? And networking is a very broad topic, as we sort of covered with the code. It's everything from the network drivers all the way up to the load balancer. So I think people do wrestle with this. And I think the short answer is, I mean, my feeling is probably no, not enough time doing user support on this, or rather the user support perhaps would be ameliorated if we had better documentation and better examples. I think a lot of people wrestle with the same basic issues that we've done a relatively poor job of documenting. Anybody want to disagree with me on that? I'm happy to be convinced otherwise.
No, I think I'll echo that.
So let's go through the questions first, then we can talk about it. Is the balance between new features and stabilization good over the last 2 releases? So over the last 2 releases, like what is the perception from the peanut gallery there, the large number of quiet people on this call, what is the perception in terms of our balance of network development and features versus stability, documentation, testing work that we do? How do you guys feel about it? There's 28 people on this call and really only like 4 people talk on a regular basis.
Well, from my perspective, honestly, I don't even know what we have done for stabilization, at least from things that have come directly as an outcome of the activity of this SIG. I have no idea if there is anything that we've done for stabilization and documentation. So maybe the balance is very skewed towards new feature development and design.
Other thoughts? Anybody?
I personally felt a little frustrated by the speed at which some of the stuff gets done. It doesn't seem like we are going as forward as quickly as I would like to. Partly that's we can't necessarily achieve consensus on some of the stuff because some of them are hard problems.
I think that's true. That's partly lack of review bandwidth. It's partly lack of a fire under our butt. And it's partly like unsureness, at least on my part, of how to make these changes safely.
Yep. Yeah, I'd echo all those as well.
Truthfully, there's probably 100 things I'd love to see done in the networking space that I could just rattle off right now. But I'm not sure how to do all of them all. And I'm not confident that we have the testing in place to make sure we can do those things safely. Like I know on our end, Zihong's back here in the back of my room. He's been doing a lot of work to help DNS scale up. And DNS is not really a topic that we've talked about much here in this SIG, but I do think, and this is an opportunity for somebody to argue with me, I do think that DNS being a core network service of the system does fall under the SIG's purvey. Bowie is also in the back here, has also done a lot of work making DNS scale better, making it perform better, actually measuring it for the first time like ever. So DNS is in. Minhan's over here too. He's spent a lot of work on the drivers and KubeNet and porting all that stuff and working on CRI. We have a lot of features that I'd love to see done, but I'm not sure that the testing is solid enough. I mean, what's our number one flaky test over and over again? It's kube proxy, right?
Up and down.
Or services yeah. Up and down, right? Yes, there we go. There's never been a release where that test hasn't come up flaky. Okay, so anyway, I guess that's answering that question.
This is Bowie. So in terms of the person who was talking about stabilization, is there any broad segments that are viewed as not stable that should be tackled?
That's a good question.
And it doesn't have to be answered now, but maybe we should answer it as a community. We want to put effort into something, we would figure out what the stack rank of things to put effort into is.
I was not suggesting that it's not stable. I was just saying that the activities of the SIG network group have done little so far towards even worrying about stabilization and documentation. For instance, I'll give you an example. We spent 3 or 4 months designing a network policy APIs, but we did not even worry about providing an implementation of network policies APIs that works, for instance, with Kubernetes. So, we have created this API without worrying about how would this work with the rest of everything else in Kubernetes. For instance, how does that work with Ingress? So that's why I was mentioning that. I don't think it's unstable. It looks pretty stable to me, actually.
Okay. Next question on this reflection list was, how do we feel about our test coverage? Docs completeness, number of open bugs.
Not great.
I mean, our docs are, I guess, on average, no worse than the rest of the docs, but that's a pretty low bar. And we are working on that. For what it's worth, picked up on this. We actually have real tech writers working now. They took a look at our docs and shook their heads and are getting into the meat of it, but they've got a lot of work in front of them. But I do think our docs are not great. I know we have a lot of open bug reports that we have not had time to reproduce or investigate. This goes back to what I said earlier with networking being one of the things people really struggle with at the beginning. I think probably half of the open bugs around networking are probably not actually bugs, but they're just ways for us to tell the user they're doing something wrong, or they followed a bad doc, or they forgot a step or a flag or something. And then test coverage. I think it's not terrible, but it's not great either. EDE coverage is actually probably not real bad. I think it's actually pretty good.
I feel like we are missing the performance testing. We don't have a benchmark either for any of our network stack. So, like for 1.5, for 1.4 release, like just before release, someone in our team actually found that there's a performance downgrade due to the different operating system we ran on. Right? So that's purely manual and then random bump into it. We don't have any benchmark yet. So that's one big missing pieces right now.
That's a great one. Okay. All right. So, sorry, you're saying?
Yeah, I don't know, Tim, like for these things, I don't know if the answer is sort of online in this discussion. Would it be worthwhile circulating a doc?
So I sent this email out at the beginning of the month, and here we are talking about it. It would be great if there are 20-something people on this call. It would be great if everybody looked at that doc and just gave it some thought about things we could do better. I mean, some of them are obvious, like we should have better docs, but if we can get a little bit more concrete than that, that would actually be really helpful in figuring out where to spend our time in the coming release. And that way we can trade off that effort against, should we bring network policy to GA or the other 5 or 6 things that are on our roadmap today, or sorry, not a roadmap, on our agenda to talk about today. There's a bunch of stuff in there. There's a bunch of PRs that have been open for a while that really need to get merged, and I apologize for some of those, but we need to figure out, like, are those the most important and impactful things that this SIG can be delivering, right? If we think of 1.6 as a pay down release primarily, which I would like to advocate that we should, what are the things we can do to pay down some of the debt that we've accumulated? This is not unique to our SIG, by the way. That's the project overall has accumulated debt, as any good project should, and occasionally we have to take a hit and pay it down, right? So I guess I don't want to monopolize the entire meeting today. but I do ask that everybody go back to that email and put some thought into to pay down the bits of debt that they think affect them the most. And paying down debt can include closing out bugs, and we've got a bunch of open CNI related bugs. We've got a bunch of docs related gaps. We can just go back and fix those things.
From my perspective, I don't really know the first place to look if I wanted to find all of the debt that exists. And I certainly know about some that I'm familiar with, but is there a place we can, as a group, sort of centralize that so we know what things are on the table to try and stabilize in 1.6?
Sure. Would it help? Like, I can craft up some GitHub search queries that will sort of show us all the bugs that are related to the topics that I think fall under our charter. And then we can at least have a look at those bugs. I think that it's, I don't know the number off the top of my head, but I'd be surprised if it's less than 3 digits.
Are you thinking of one repo or several?
Well, I mean, the primary repo is where most of our bugs are going to be. Although there is all the ingress stuff, the load balancers is in a separate repo.
And the doc is in a separate repo.
And the docs are now in a separate repo, that's true. But if I crafted a bunch of links and sent them out to people sort of as food for thought with respect to this, would that help?
I'd be happy to see.
Yes, it will help.
Yeah.
Okay. I will take that action item then. Okay, the last part of this was we should think about our charter. We've never really written a charter for the SIG of what we think is in scope. I just listed out 15 things that I think are related to networking, but I don't think we've ever actually formalized that. It would be perhaps interesting to try to write that down. Any volunteers?
Do you have that list posted somewhere, Tim?
I'll happily rattle off what I think is sort of in scope, and then it would be interesting if somebody else could try to define the bounds of that a little bit more crisply. Right.
Well, why don't you throw them out? I mean, if nothing else, we can put them on a wiki page or send them to the mailing list and try to flesh them out a little bit more.
All right, I'll write that in email. Just
Yeah.
so we need to do it now. All right, so I'll take away those 2 actions. You want to move on with the agenda?
I think so. So I think the actions coming out of that is for everybody to go back and look at the email you sent around that hasn't thought about it yet, and we should respond to that with any thoughts we have.
Okay. Who's driving the agenda, Dan? Casey?
Casey this time.
Yes, I think that's me. So let me just go back to it. So we kind of covered the first 2 things there, sort of. The self-assessment, and then the next thing on the list was 1.6 goals and task owners, where sounds like we may want to prioritize some stabilization. Joji had suggested multiple interfaces as a discussion. Is Joji here?
Yeah, I'm here. Yeah, so recently we've been getting a lot of requests for this. The use cases that we've been pointed at, I mean, people have been pointing to, is one is related to OpenStack, where they have a requirement to separate out some of the traffic. They would like to actually use interface level separation for isolation. That is one use case. And there was another use case where people would like to implement network functions inside a pod that will also require multiple interfaces. So those are 2. So I know we were looking for use cases earlier.
What was that second one? Implement one inside a pod?
Network functions inside the pod. So like you might implement a router, for example.
Okay. And on the first one, was that Kubernetes on OpenStack or OpenStack on Kubernetes?
It's Kubernetes on OpenStack.
Thank you.
Yeah. So those are the two use cases that has come to my attention.
Could you explain why you would have multiple interfaces, or what you mean by interface level separation, please?
Could I explain? Yeah, sure. So basically, there is a perception that if you isolate traffic at the interface level, it's better isolation than isolating them using some kind of policy like an ACL or something like that.
So you want to have separate network interfaces with separate IP addresses for services and stuff?
Exactly. I mean, so typically, I mean, you might have, for example, like a monitoring network or a control network or a storage network that people would like to send their traffic separately on. That's why they would like to have separate interfaces.
Coupled with multiple networks. It's not just multiple interfaces.
I'm sorry?
This, the use case, at least the second one, sounds like it's intimately connected with multiple networks and explicit control over networks. It's not just multiple interfaces.
I mean, multiple interfaces would automatically mean multiple networks.
Well,
no?
You can,
think
so I think there's the ultimate abstraction, the ultimate data model for this, which involves a noun for network, which implies interfaces and control, abilities, APIs that lets you decide which pods join which networks. And I think that we probably will get there, but I think there's probably an intermediate step, which would be to allow multiple interfaces without having Kubernetes itself be aware of that fact. So hypothetically, what stops people today from dropping two different config files in the CNI directory and having two different CNI plugins run?
Partly that's the CNI driver, because it picks the first CNI config file, because we never decided what to do about multiple networks.
Right.
Problem with running both of those files would be that they would get run for every single pod on that particular node, and that may not be exactly what you want.
Now, there's another thing to note, though. Even if Kubernetes runs only one CNI plugin, somebody writes that CNI plugin. Maybe it makes multiple network attachments.
Yeah.
The one drawback.
You can have the single. You can have single CNI driver creating multiple interfaces, multiple networks too.
Yeah, you can have a CNI driver that wraps on the driver.
Interface, it can only return one address.
Yeah, so that is a bottleneck at this point, I think, because Kubernetes inherently only assumes a single IP address for the pod. So if you do any kind of API or a kubectl command, it's only going to show one IP address.
Part of that is a issue with CNI's result object, and I've done a bunch of work upstream in the last month or so in CNI to allow passing back arbitrary numbers of interfaces and IP addresses.
Exactly.
That will continue.
Yeah, maybe we should more seriously pursue that is what I think I'm proposing.
Yeah, can we just digress and talk about the status of that, Dan?
Sure. Do you want me to give a quick update?
Please.
Yeah, so the actual code for allowing multiple interfaces and multiple IP addresses has been around for a while, but it's because we have to change the result structure that gets passed from the CNI plugin back to the runtime like Kubernetes. It's intimately tied in with versioning. And so we've spent a lot of time discussing in the CNI project how to make the CNI code that Kubernetes and other runtimes use, as well as the spec itself, work with both old and new formats or old new specifications. And so that was a large amount of the effort, was to actually develop a coherent versioning strategy for CNI. Like I said, I've done a bunch of that work. It's in CNI issue number 145, and that's currently on review from a bunch of other CNI maintainers. And it does preserve backwards compatibility for old plugins.
So when you say that you're working on the ability to have multiple interfaces, multiple IP addresses per host or per pod?
Per pod.
Per pod, okay.
Yep, this would allow the CNI plugin to return an array of interfaces and those pod interfaces and host interfaces, as well as multiple IP addresses, either IPv4 or IPv6. And those IP addresses could be attached to any of the interfaces the plugin passes back. So at least at that point, at least the CNI plugin would have the information, and then we need to plumb some of that through Kubernetes.
Okay, so it sounds like there's good legwork happening there. But let's do a reality check. This is one of those features that is going to get implemented when somebody implements it. And it's not, I think, the sort of thing at this point that we can throw out and that the core team of people who are currently working on stuff is going to implement. I mean, I don't know about, I can't speak for Red Hat. I know that it's not a driving requirement for Google, and I don't have any staff that I'm sparing for that right now. This is a place where I need people to step up.
Okay.
I'm happy to review design, to help craft the design for it, and to help shepherd the overall design through, but I need somebody to own it. I need somebody to be responsible for writing the design doc, comparing the different options, figuring out what doesn't work today. It sounds like Dan's already got a lot of that in his head. Figuring out what doesn't work, how we can work around it, what the implications of those workarounds are for the system at large, prototyping, implementing, testing, and documenting. This is not a small feature. And it has some real ripple out into the system. I think it's something that we do want. I think this is a great opportunity for somebody in the community to step up and help out.
I'll be happy to help out.
Who's that, Joji?
Yep.
What is it talking about? Implementing what exactly? The Kubernetes side of this, I assume, not the CNI side of this.
Both. I mean, end to end, right? Like,
yes.
I think there are multiple steps of development that we can do here. The minimum would be make CNI in Kubernetes support multiple IP addresses.
Yep. And so, I'm happy to take over that portion of it since once I get the CNI stuff upstream.
And again, you're talking about multiple IP addresses per pod, not per host.
Yes, correct. So find a way to report that through the API. You know, how do we designate which IP is for what, or do we? Right? What does it mean for testing? How do we get test coverage of this? How do we document it? What's the appropriate way to describe it? Like, what is the actual use case that we expect people to use with this? Those sorts of things. It's going to just need an owner for end to end. I think it's an awesome idea. We just need somebody to do it.
Okay.
So if Joji, you're signing up for that, it sounds like Dan's got a lot of context that can help you with it.
Yep, I'm happy to help with it.
Yeah, let's do that.
All right. So I guess first step would be sort of maybe something that analyzes the existing problem and says, these are the things that don't work, and here's the work that's in flight, and here's what we think we need to do.
Okay.
So is this supposed to be part of 1.6?
That's a great question.
What's the timeline for 1.6?
About 3 months. So we would expect a code freeze around February.
I would say a significant portion seems doable by then. So maybe tentatively say 1.6 for it. Maybe we can walk that back eventually, but I think right now it seems possible.
So what is the envisioned strategy for getting these IP addresses to the pods? I mean, are there supposed to be different host networks configured, and you're saying this pod should get IP addresses from both networks from the host, or just yet another IP address on ETH0? I mean, how do you?
So I would say the first step would be that if you are writing a CNI plugin, that plugin can create one or more interfaces for the pod, and that plugin can assign one or more IP addresses to any of those interfaces and successfully pass them back to Kubernetes. I wouldn't necessarily envision specifying multiple CNI files yet.
Right. It raises questions about IPAM. the case I've been discussing this past year, I don't need additional IPAM input. And to remind people, I've been thinking about how to put Kubernetes on tenant networks, using isolated networks for each tenant and multiple setup. So my thinking was I would like to be able to return a floating IP.
We have trouble hearing you, Mike.
I'm sorry. I've been thinking about making my CNI plugin return a floating IP to be used by the kubelet when probing the pod, the regular IP, which is the IP on its tenant network. And so for that, I don't need any additional IPAM input. I would have something global built in at the operator level, telling my CNI plugin how to make a floating IP that the kubelet will use for probing.
With that floating IP, would you use that floating IP in service constituency?
What's the question?
So if you assign a floating IP, if you return a floating IP here, that floating IP is what kubelet is going to report to the API server.
No.
Oh, no.
No, well, again, we're talking about reporting multiple IPs to the API server. So the main IP, the one that gets used for damn near everything except the exceptions, is the main IP, which is a private IP on the tenant network.
Got you.
IP would be the exception, and it would be used by the kubelet. I would have to introduce also an exception or an alternate path to the kubelet to make the kubelet use that floating IP program.
I'm having a really hard time with the sound on today's call. It's not just you, Mike. It's other people are just sort of fading out. Is anybody else having this?
I can hear most people fine, except for Mike.
Okay.
I mean, I think what Mike is talking about is something that we discussed a couple months back as well, and there actually is an open issue where we are tracking some of the stuff about multiple IP addresses per pod.
Yeah.
And if I remember correctly, Mike's request was to be able to use a certain IP for health check and the other IP for everything else.
Right. Yeah, I paged that back in while he was talking. The way I think of it is, if we're going to return multiple IPs, we might want to discriminate which IPs are used for which purposes.
Right.
Yeah.
Right. And where I was going was thinking more about Joji's cases, which I've also thought about, but haven't brought up in the. But I'm also interested in doing stuff like injecting network functions. And so once I go beyond the use case that I have talked about, I start wanting to talk about explicit networks and maybe IPAM on each of those networks. And so it kind of bleeds into a bigger story. So that's why I characterize this discussion of the CNI thing as a digression. I think Joji has raised, a big question, and we can't answer it just by focusing on the CNI.
So I think this is a great place where we can jump off and say, these are the things that the first ordered proposal doc should cover. Because I think you're right. I think that the final solution does involve a noun for networks and some higher level sort of admin APIs to go into this. But I don't know that that's the first deliverable. It's certainly not the MVP. And this is the place where the design proposal can start to cover like generations of solution. So it sounds like Mike is signing up to help craft that design doc, or at least review it, poke holes in it.
I'll review it, sure.
Okay, great. Yes, actual progress, great. Next topic, the 2/3 through our meeting.
Yeah, running out. Dan, you had raised node ready conditions.
Yep. Yeah. So that was there was some stuff that I think Justin had pushed and gotten merged for node ready conditions on AWS that dealt with admission control and such. And I seem to recall that Jordan had some problems with that approach and had suggested a completely alternate approach. And I was wondering, Tim, if you knew where that eventually landed. Was going to get backed out and somebody was going to go with Jordan's approach instead.
I mean, this also goes to the initializers discussion, and it also goes to your PR, right? About the flag to the kubelet.
Yeah, although I think Jordan's suggestions, if that's the way things go, would obsolete my PR as well.
I didn't get that.
Maybe.
So I didn't pick that part up if that's true. So do you want to, I don't know that everybody's familiar with the problem. Do you want to give like a 1 minute or less description of what your PR was trying to solve? Because I think that's fundamentally the problem.
Okay. Yeah. So the fundamental problem is that there are some network plugins that are local only. For example, the KubeNet plugin. The KubeNet plugin just sets up a Linux bridge and assigns a range to the bridge, and pods get stuck on that bridge. The KubeNet plugin doesn't know anything about being in a cloud. It doesn't care about being in a cloud. But yet when you run Kubernetes cluster with the KubeNet plugin in a cloud like Google's or Amazon's, you need to set up cloud routes between the nodes so that the traffic from the pods can get to the other nodes. And of course, the issue there is that there's two ready conditions. First, KubeNet has to be set up. And second, the cloud routes have to be set up. But the cloud routes only need to be set up when KubeNet is running in a cloud, and KubeNet doesn't know anything about that. So there currently is only one node ready condition, and that node ready condition gets set whenever a cloud provider is set. But that only gets cleared, and thus the node only becomes ready when the route controller actually adds routes for that node. And that doesn't necessarily work for everybody because not everybody uses cloud routes, even when a cloud provider gets used. So
that was a little bit roundabout. Like,
yep.
Can we cut to
okay? So
what actually happens bad?
What happens bad is that the node not ready condition is set on the node when you're using cloud provider, but because nothing uses cloud routes necessarily for certain plugins, that condition never gets cleared. So some of us have hacks in our plugins to go specifically look for that condition and clear it, even though it was never needed to be set in the first place. And basically, this kind of ties into how do all of us who write CNI plugins for Kubernetes tell Kubernetes that our plugins are ready, and are there external things that our plugins need, like cloud routes, that also need some ready conditions, and how do we notify those?
So just as one more bit of background, the reason for this condition is that in cases like Google Cloud, the node might be up, but then the route is not yet. And so what the worst case happens is scheduler ends up putting a pod on that machine, and it goes nowhere because it doesn't have any network because the route hasn't been set up, and then everybody has a bad day trying to figure out what happened. And eventually the route controller catches up and things proceed, and then the poor debugger has no idea why it just started working. Not that this happened to us. And so we added this condition that says don't allow anything onto the node until after we've set up the route. But if you're running any other plugin that doesn't need those routes, then that's just a bunch of wasted time, right?
Yep.
Or I mean, potentially wasted time, or it might never happen.
Yeah. So I didn't necessarily want to take up a ton of time with this. I was just wondering if there was additional movement on where that was going to go, and if you had seen or had opinions on Jordan's approach.
I don't recall what was Jordan's approach, but I spoke with Clayton and Justin at KubeCon 2 weeks ago. By the way, it was nice to meet everybody there. And I spoke with them about this generic initializers idea, which I think is something that we need for the system overall. The idea being there would be some way to configure a list of essentially gates that were installed on a node when the node was created. So as part of admission control, I create a node, the admission controller, it says, okay, the gate that you have asked for is routes. So I'm installing a gate called routes, and nothing will happen until, this object is not considered ready for use until that routes gate is released.
Doesn't that overlap a little bit with scheduling though? And I think that was what Jordan's suggested approach was.
I don't think it overlaps with scheduling. I'm not sure how. I'll have to go back and read Jordan's notes.
Okay.
So my feeling was, Dan, I read your PR and I hated it. And I thought, and I talked with Justin and I thought about this initializers, and I just can't come up with a better answer. So
yeah, I'm not saying I like it either, but
so I'm pretty close to rescinding my hate. unblocking this. I just need to find a block of an hour or two to really sit and chew on it a little bit more.
Okay.
I promise that we will unblock this very soon with one solution or another. I'll go back and read Jordan's because maybe I missed that he actually had an alternate proposal.
Yeah, he did. At least an alternate one to Justin's attempt. So
Okay.
Okay, that's probably enough on that one.
This is again a case where I'd like to hear from other folks who are doing other crazy things with plugins. If you have other ways of this sort of interlock that we're not considering, things that you might need from it, then please take it either to a bug or to these particular threads and let us know. You can search for PRs open by DCBW and you'll find it.
Cool. All right. Yeah. So the next one is also Dan.
Yep. And actually, let's just skip that one in interest of time.
Sure. So I wanted to talk about microservice mesh docs that have been circulating.
Okay. That's probably me. So I guess we hadn't really had an awful lot of time to talk about this in the SIG, and I guess one of the initial suppositions is that this is probably the right SIG to talk about this stuff.
I think it is.
It's hard to think of another SIG that is a better fit. Although Tim, you brought up scope of the SIG. Obviously the work that's involved with microservices mesh starts to span other areas like auth in particular and multi-tenancy. So we'll probably be bleeding across SIGs. So I guess there's a couple of different things that I wanted to talk about. Enrico sent out a document talking about how we might do sidecar proxy injection either per pod or per node. This is based on the supposition that we actually use sidecar proxies to do a bunch of this stuff. I think that's probably a reasonable supposition given what Linkerd has done and what Envoy and what Amalgamate have done in this space.
Does everybody on the call have context enough to be this far into it? I've spoken to Louis before, so.
I'm familiar with Amalgamate, but not the others.
Okay. So I can give a brief overview of what I think has been going on in the industry. I see Williams here too from Linkerd, so he could probably chime in just as well as I could about the emergence of things in this space and why people are interested in them, if that would be helpful.
I think it would be. I think we're entering a new layer of the stack that this SIG has not really spent a whole lot of time in.
Okay. So this primarily comes from an L7 view of the world, right, where you have a whole bunch of services talking to each other, let's say primarily over HTTP, and a world where you have pretty crappy L7 client libraries for doing that work, and people want better behavior out of their L7 stack, whether they want load balancing, so like the existing Kubernetes load balancing L3 or L4 load balancing mechanisms don't really work all that well for services or virtual services like this. You also want to be able to monitor this traffic in a kind of standard and uniform way and be able to reason about it and to be able to control it, maybe to be able to authenticate it and have the mesh of services understand what this authentication means holistically without the application developer having to do an awful lot of work. This is largely a pattern that Google has solved for itself internally by building really heavyweight client libraries that cost man years worth of effort and aren't in a form that we could really realistically ship over the wall beyond our efforts around gRPC. If you look at what other companies have done, and you could probably say that Netflix has probably got the most brand awareness in this space. They built client libraries that provided some of these higher level networking functions, these L7 functions. So there was Netflix had their Prana sidecar. They also wrote Ribbon, which is a library solution to this problem. And then you can look at things like Finagle, right, which came out of Twitter and is now being used by Linkerd. Again, a kind of heavyweight client library solution to the problem which Linkerd has now packaged up into a sidecar proxy to provide the equivalent behavior for HTTP traffic. And there are lots and lots of people building services this way, using either fairly thin to moderately thick HTTP or L7 client libraries to talk among services. Whether they're SOAP, REST, it doesn't really matter. And they all pretty universally have the same set of problems, right? They all need good load balancing solutions if they have moderate scale. They all need good monitoring because monitoring is expensive to build, and building at end times or relying on client libraries to deliver it for you can be quite problematic. So that's kind of the baseline set of requirements. William, I don't know if you want to expand on that at all.
No, I thought that was really good. I think the only thing I would add is that, the heavyweight client library approach is also what we did at Twitter, but I think as the world moves towards the polyglot stack, it gets harder and harder to maintain that approach. So that's why I think there's an interest in proxy.
Yeah. I mean,
actually, getting on to the question I wanted to ask about, which is, to what degree can this be separated through what looks like a network interface, and to what degree do you really want to be solving these problems in a client library that's integrated in the client process?
So, I mean, this is largely a question of cost, I think. Anybody who has large-scale deployments, the people I've talked to, certainly the larger companies, they tend to have diversity problems, right? So they start off with maybe a couple of languages, maybe Go, Java, C++, and then they acquire a company or they acquire technology and that's using PHP, and then they acquire something else and it's using Node.js. While they were able to consume or develop the FAT client library in 3 of the languages to make sure that everything was going to the right logging system, the right metric system, they eventually run out of engineering manpower to keep up with the diversity in their ecosystem. I've talked to quite a number of companies that have had that problem. And I'm sure William has too, because that, is one of the main points of Linkerd. So yeah, engineering diversity is a real problem. It's a problem internally at Google. We do use a sidecar solution to solve this problem, particularly the thick client library problem, right? Where we have storage systems that have fairly thick stateful clients to be able to do efficient work. But we can't afford to develop those thick client libraries for the end languages we run in production, never mind the end languages that we also support as services or for our customers of our services. Right? It just becomes untenable. I recently got pinged about writing a client library in R for our machine learning services, and that would become right. You get an idea of how prohibitively expensive this becomes quite quickly.
Right. On the other side of it, some of the functionality logically has to be in the client process. I'm thinking in the Netflix case, for example, the historics, circuit breakers or the fallback actions happen when you don't have the network connectivity.
Well, certain classes do and certain classes don't, right? So fallback actions like retry and failover do not have to be in the client process, as long as there's some understanding at the protocol level about idempotency or how network failures are supposed to be reasoned about. Yes, some of the more advanced ones do belong in the application layer, but then they're probably application specific at that point.
So do you envision that there might be the ability to specify that traffic should flow through a service or a series of services implemented as a proxy running in a pod, I'm guessing, and that these sort of things can then be switched into the traffic path in a similar way, or maybe by the same mechanism by which we are currently putting network policies into the traffic path?
Yes, so definitely one of the goals is to be able to inject this behavior into existing deployments without requiring the existing deployment to make changes.
Right, and so do you think that using the network policy mechanism is the right thing, or do you want to have a completely new mechanism for that?
So I don't know if network policy is exactly the right mechanism. I think one of the things I wanted to talk about was about ingress, right? Because ingress is a Kubernetes configuration mechanism designed to talk about traffic coming into the cluster from outside primarily, although it can be repurposed. a lot of what this really, a lot of these higher level networking functions, you want to be able to tie to some kind of DNS addressable thing, particularly when you're talking about HTTP traffic. So it's almost like a virtual service that's really specifying a bunch of rules about how traffic should route to downstream services. Some of the policies are fairly implicit, and things like retry and failover. Yes, you might have knobs to tune behavior, but HTTP, the protocol itself, actually says quite a lot of things, and there are quite reasonable defaults for a lot of the behaviors. I haven't taken a detailed look at network policy. Maybe Tim, you could steer me in the right direction here, but it didn't seem like quite the right kind of thing for the type of traffic we were talking about here.
That's my feeling. I don't think network policy, as it's currently defined, is the right thing. And we should think about, whether evolution of network policy is the right thing or whether something else is the right thing.
Yeah. So if I think about the requirements that I've heard, the thing today in Kubernetes that's closest to the thing that we want, well, there's service, which is a good start. A lot of the features that people ask for are around routing, traffic slicing. So ingress is probably the closest thing on that side of the fence. And then there's load balancing, which is really, L7 load balancing isn't really covered all that well by existing Kubernetes config at all in any of these places, except the implicit stuff that ingress controllers do with services that are bound to routes.
Another question that I'm wondering about here, to use a sidecar, you either have to, the current network interface is, IP. To inject a sidecar that does something, it either has to first do a bunch of IP tables rules to capture traffic to services, or use a different programming model where the main part of the pod is connecting, to local-host / service theme or something like that.
Right.
So,
yeah.
Which are you thinking here?
The former. So Enrico's doc does a pretty good job capturing this. Given that, at least the presumed goal was that we should be doing this transparently, or reasonably transparently. The assumption was that the applications didn't have to make changes, which I think is implied by the latter part of your statement.
Okay. Where did we find Enrico's doc again?
He sent it to the Networking SIG mailing list, so I can probably dump it into the chat and make it clickable. Or Enrico's also dialed in here, by the way. So
yes. Yeah.
While you look for that doc, I just wanted to say I work for a large bank, and this idea of having out-of-process proxy and being able to take our thousands of legacy apps out of where they are and put them into a more modern environment is a big deal for us. So not only, Louis mentioned the language sprawl, which affects us as well, but also a huge legacy base that we hope to be able to bring across into this model.
Yeah, so we mostly talk about this in the context of proxies, but the other thing that sidecars provide is kind of a way to give you thick client libraries without giving you thick client library development issues. It's probably not going to be something that we may focus on initially, but it is something that would be quite useful to the use cases that were just described.
Isn't this similar to service function chaining, term that is used in the networking industry, wherein, say, you want traffic to go through a firewall without changing the IP addresses?
It is somewhat similar, yes. I've had conversations with people along those lines, I would say. Obviously, if you can inject a proxy, then you can inject behavior, and that behavior could be things like access policy or authentication mechanism or load balancing behavior or like any manner of things, really. So yes, they are quite similar in spirit. And maybe in specification, I don't know. Again, I kind of defer to Tim about what the right vehicle for expressing this behavior is. I worked on these systems for quite a long time, and usually what they have internally is some chain of behaviors of this type that are enforced, and there's just some implied ordering because there's only really one central order of enforcement.
So the problem that I wrestle with entering sort of NFV territory is NFV sort of depends on a really programmable network, right? And a lot of what people are trying to do with Kubernetes is to cut out the overlays and to get down to more direct networking. Obviously, that's not going to be everybody, and there's a trade-off to be made here of control and manageability versus performance. And so that's where my brain sticks, and then I realize that I just don't have nearly enough experience with NFV to go much further with it.
I have a bit of background in network and spoke with Chris Marino on the, who's working on the, now I'm getting his, thank you, Romano. And I think that unfortunately there's a lot of terminology overlap in between the network world with network service function chaining and NFV and these sort of things. But my personal opinion is they're pretty separate things. I think that operating at different levels, this sort of proxy stuff is more at the 4 through 7 sort of application space versus like packet level networking stuff. It just seems different to me, even though the terminology overlaps.
Yeah, I work with Chris at Romana. We've been discussing these concepts of inserting functions into the data stream, and I think Michael, he told me about the conversation he had with you about where you mentioned that they are very, very similar. For us, as those who are trying to implement this behind the scenes, there's a lot of similarity the way this is implemented, but we understand that these are potentially very different use cases and possibly the need for a different interface even for people to work with those. But we're working on something, and we will see what that looks like in the end.
All right, guys, just want to raise that we're at our 3 o'clock limit, so maybe we should take the rest of this conversation to the doc or the mailing list. Louis, is there a particular call to action that you would
I think the immediate call to action is to read Enrico's document about how these proxies are expected to be injected into the network. That's probably the most immediately tractable thing. I mean, obviously we want, from the Kubernetes point of view, we want to be able to have this mechanism work in a proxy vendor independent way, so anybody can bring their own proxy. So that's probably the most immediately tractable work item to deal with in Kubernetes land. I mean, the actual behaviors of the proxies and what they do is something that doesn't strictly have to live in Kubernetes or in the networking SIG at all, right? I mean, because vendors could provide, and other open source implementations of proxies could provide a wide variety of features in this space. So yes, my primary concern is to make sure that we can kind of come to agreement about the injection process and what that looks like, how it should be integrated into Kubernetes itself, because there are performance concerns around how you consume all this information from the APIs and listen to changes in the network. So I think that should be the primary focus. There are other documents that we sent to the networking SIG about orthogonal but related issues, as well as the high-level introductory document, which if you haven't read, I'd recommend people take a look at it.
Okay.
All right.
All right. Well, thanks everyone. I'm sorry we didn't get to everything on the agenda. At Dan Winship, I started looking again at that PR and playing with a few things regarding the policy. I think we should make a decision, order soon, and either commit to fixing it and all the code generators and convincing Clayton that he's wrong, or commit to abandoning the idea.
Okay, yeah, I'm leaning towards abandoning the idea. I guess I'll send email to the list.
Okay, I just responded to the PR. I'm sort of leaning in that direction too. The engineer in me really wants to fix it because I know it'll come up again at some point later, and then we'll curse ourselves for not having fixed it. But I'm not sure that it's the best use of time in the medium term. Or put another way, I've looked at those code generators before. They're hard to fix.
Yeah.
Okay. Thanks, everyone. 2 weeks?
2 weeks, yep.
Okay.
Yep.
Thanks, all.
Thank you.
All right. Bye.